A second type of depreciation is called reducing balance depreciation, and another name for this is diminishing value depreciation. And it's called diminishing value depreciation because it's calculating the value, on the new value after some depreciation has been taken off it. So diminishing value depreciation. It's a little bit like compound interest, where in compound interest we calculate the interest on the new amount after the interest has been added on. Here we're calculating the depreciation on the new value after it's already lost some of its value. So it's where the object or the asset is depreciating by a constant percentage each year. Unlike flat rate depreciation, which depreciates by the same amount, this depreciates by a constant percentage. So the book value here is P, the purchase price, times 1 minus R on 100 to the power T. And you can see how it's very similar to the compound interest formula, except we've got a take away there instead of a plus. So P is purchase price, R is rate of depreciation, if I can fit that in. And I forgot to put T, so we'll have to put T in ourselves. T is time. And can we just make a note that time and rate of depreciation have to be in the same unit? In same unit. Another way we can write it would be P and then capital R to the power T, where R is 1 minus little r over 100. R is the rate of depreciation. What I would suggest you do when you're doing these is use your E activity, so FM business, depreciation, and choose reducing balance. The other way of doing it is to use the TVM solver like we used with compound interest, but because we're depreciating, so it's losing value, we have to have a negative interest rate because we're losing value, so it's going down. Okay, looking at our examples here. The first one, we've got a butcher buys a meat lever for $5,000 and it depreciates at a rate of 16% per annum using reducing balance depreciation. Find its book value after 4 years. So we're trying to find book value. We know purchase price was 5,000. The rate of depreciation is 16% and the time is 4 years. So book value is 5,000 times 1 minus 16 over 100 to the power 4. I always prefer, if I'm doing it on my calculator, to do 1 minus 16 over 100 is, I'm finding 84%, so 5,000 times 0.84 to the power 4. And then if I work that out on my calculator, it gives me 5,000 times 0.84 to the power 4, $2,489. It doesn't tell us what to round it to, so we'll round it to the nearest cent, so 36 cents. Now, a way you could have done it on your TVM solver, your financial solver, on your calculator, is by saying N, capital N, is 4. I is, we're doing depreciation, so it's negative 16. PV was what we spent, so it's negative 5,000. PMT, we're not doing anything with, is 0. Okay, and FV is what we're trying to find out. Okay, PY and CY you just leave as 1. and then you solve for FV and you should get $2,489.36 again. And FV is positive because it's if you sold it, you're going to get that $2,489. Okay, in this next example, we're being given office furniture is bought for $8,500. It has an effective life of 6 years when it's scrapped for $1,000, and we want to find the rate of depreciation now. So this is where either our E-activity or our financial solver is useful, because otherwise we have to rearrange it and it's going to be kind of hard. So we're going to go book value, okay, that's what it values when it's scrapped, so $1,000 here. The purchase price was $8,500. The effective life, so the time, was 6 years, okay, and we don't know what R is. So on our calculators, if we use our E-activity, we're going to do 1,000 equals 8,500 times 1 minus, we don't know what that is, R on 100 to the power 6. And you can just leave that, that's the only working out you need to do, and then on your calculators you can work out what R is. If you want to use your TVM solver, which is the way I'm going to do it, okay, N, we know N is 6 years, we don't know the interest rate now, we know the purchase price was 8,500, make it negative because we paid that. PMT we don't need to worry about. FV is the future value, and that's what we get given, so that's going to be positive because if we sell it we're going to be given that $1,000. PY and CY are going to equal 1. So I'm going to put that into our calculators and solve it for I. So 6, we don't know what I is, we're going to expect it's going to be negative. PV is negative 8,500, PV is 0, FV is 1,000, and we're solving for I, and it gives us negative 30.00. Okay, so that's depreciating by 30% per annum, and if you did it on your E-activity you should have got the same value. Now in this example we're looking at comparing flat rate depreciation with reducing balance depreciation. It's asking us to draw a depreciation schedule for both methods for over 5 years. So in a depreciation schedule we have to draw for each year, we work out the depreciation and we also work out the book value, and then what we're going to do is compare them. So first of all I'm going to do flat rate depreciation for 5 years. Okay, so we're going to go depreciation and then book value in this case because I can find my depreciation first. So after 0 years, 1 year, 2 years, 3 years, 4 years, 5 years. So after 0 years there was no depreciation. The book value was what it was originally, 7,800. Then after first year it's going to have reduced by 15% of 7,800. So I'm just going to work out 0.15 times 7,800, which is 1,170. So the book value is going to be 7,800 minus 1,170, which is 6,630. Okay. And we're going to just take off 1,170 each time. When we're doing our depreciation schedule, we just work out the depreciation each year. We're not adding it up. So each year it's just depreciating by 1,170 every time. So we're just going to then take off 1,170 each year. So next one is 5,460, and then after 3 years it's going to be 4,290. After 4 years it's going to be 3,120, and after 5 years the book value is going to be 1,950. So that's using flat rate depreciation, okay, 15% per year. Next one is we're going to look at reducing balance depreciation using 10% per annum. Remember, with reducing balance, the depreciation is not the same every year, it's going to be different. And book value. So after 0 years, it's still going to be, depreciation is going to be 0, book value is going to be 7,800. After 1 year, it's going to depreciate by 10%. So 10% of 7,800 is 780. Book value is going to be 7,800 minus 780, which is 7,020. Then we work out 10% of the 7,020. So 10% of 7,020 is 702. And so what we're doing there is 7,020 minus 702, which is 6,318. Then, after 3 years, so in the third year, the depreciation is 10% of 6,318, which is 63180. We're going to take away 631.80 from 6,318, which is 5,686.20. So in the fourth year, the depreciation is 10% of 5,686.20, excuse me, which is $568.62, and we're going to take that away from 5,686.20, which leaves us with $5,117.58. And finally, after 5 years, the depreciation is 10% of 5,117.58. Excuse me. Take that away, and that gives us $4,605.82. What you see here is the book value is just reducing by 1,170 every time, but here it was going down by a different amount, and what we're actually doing is finding 90% of that value, so we're timesing 0.9 because we were taking 10% off. We're finding 10% here and then taking it away, so we're finding timesing by 0.9 each time. And lastly, we've been asked to draw a graph of the book value of the electronic equipment over time. And what we can see is in the flat rate depreciation, it's called straight line because it's just going down in a straight line. It's dropping by 1,170 every time. It starts off being 7,800, that's the y-intercept, and the gradient is just going down by negative 1,170 every time. But in the second one, we see book value starts off at 7,800, but it's not going down by the same amount. And as the years go on, you'll see that it depreciates by less and less. Okay, and that often happens, you know, if you buy a new car, okay, after the first year, it's really dropped by a lot. Okay, but in between first and second year it drops by less, and when it's 10 years and 11 years old it's not that much difference, it only depreciates by a little bit.